For the last review that I want to do, I want to show you how to shade the regions of the standard deviations when you're asked to do that. So it says here, estimate the percent of data within the specified intervals of each normal distribution, shade the corresponding region under the normal curve, label the tick marks on the horizontal axis, and label the horizontal axis. Use the empirical rule for normal distributions. So I'm going to show you two ways to do these. And then one of them, it's like universal. But if they're not asking you that, then you can use technology. There are no formulas for these particular lessons. This is just an introduction to statistics. If you take stats next year, then you will go definitely in depth into all the formulas. I mean, statistics is not just pure letters. You have a lot of formulas, you have a lot of calculations, but for this particular unit of Algebra 2, it's a very just quick introduction to the topics. So there are not a lot of computations, okay? Some of you email me like, what is this? These are pure letters. It's just a lot of reading and writing. Yeah, mathematics is also about logic, right? But it's not all about that, okay? So eventually you will get some formulas. So it says determine the percent of adult women with a cholesterol level higher than 202 milligrams per deciliter, and given that the mean cholesterol level of adult women is 188 with a standard deviation of 24. So you are given again what is, and let's see, yeah, so in the previous examples, right, in the videos, I showed you how to identify what's the mean and how to create the marks in the horizontal axis. So this is what you got to do for these problems. But not only that, you also have to shade the region of the normal distribution depending on what they tell you. And I forgot to copy and paste here the empirical rule. So let me just do that very quickly so we know what it is. So I showed these in the previous lessons. This is called the empirical rule for normal distribution. So all what it is that this is divided by standard deviation, and each of them have each of the sections, right, each of the intervals have a particular percentage. So the only thing you gotta do is simply shade the region that they're telling you and then just add up the percentages, okay? So in this case, I'm sorry, I'm out of breath. Pregnancy makes you out of breath very easily. So it says, given that the mean cholesterol level of adult women is 188, and the standard deviation is 24, create the mark lines, the horizontal, in the horizontal axis. So 188 is my mean, and then if I add 24 and subtract 24, this is what I come up with. But then it tells you to determine the percent of adult women with a cholesterol level higher than 212. So this is key right here. Higher than 212. So I need to locate first of all where 212 is. 212 is here, and it says higher. So higher means higher, okay? Larger, not smaller. So you're gonna shade this region right here all the way to the tail, okay? Everything, it's higher. So after that, you just come here, okay? Hopefully you will, I mean, I will provide this for you. You don't have to memorize it. But if you're taking stats next year, pretty sure that you have to know this, right? What are the percentages? So the percentage here is 13. So that will be this chunk right here. This small chunk right here is this one. And then this small chunk right here is this one. So you just have to add it up. 13.5 plus 2.35 plus 0.15, that is 16%. So that's why the answer here is approximately 16% of adult women have cholesterol levels higher than 212. Okay. And that's it. So now let's do another one. Let's do another problem. So it says determine the percent of adult men who are shorter than 63.4 inches, given that the average adult man is 69 inches tall with a standard deviation of 2.8 inches. So first of all, create the numbers on the horizontal axis. What is the mean? It says, doesn't say mean, but mean also means average. So average adult the height is 69 inches tall, so there you have it. And then the standard deviation is 2.8. So you have all the information you need. Hopefully you did that correctly. Now, if it says here that you want to determine the men who are shorter than 63.4, so if you created the numbers correctly, you will know that 63.4 should be around here, right? So you want to know people who are shorter. So do you think you have to shade to the right or to the left if it's shorter, right? If it's shorter. So hopefully you said I need to shade to the left. Yeah, because it's shorter, right? So we are shading here this region. And that region belongs to 2.35% and 0.15. So that will be a total of 2.5. So approximately 2.5% of adult men are shorter than 63.4. And that's it. Okay, there's really nothing else to it. You just have to interpret what the question is asking you. Okay, for the next example, I'm not going to use the empirical rule, but rather GeoGebra. So it says, talking about pregnancy, determine the percent of pregnancies with a duration between 253 and 283 days. That's a long time. So I'm almost halfway there. Given that the mean duration of pregnancy is 268 days. So ladies, take care of yourself. You don't want to be pregnant for longer than that. And some people go 42 weeks. That's crazy. And the standard deviation is 15 days. So that means that the spread of the data is 15 days apart. And the average that women are pregnant are 268 days. That's with one child. Now, if you want to have 5, multiply that times 5. That's crazy. Alright, anyway, so I'll show you how to use GeoGebra for this. So you open the program, you go here, you go to view, and then you want to do the probability calculator. And then let's move this around. Let's see. No, let's move this one here. All right. And then the problem said the mean is 268. 268. And then the standard deviation was 15, right? The standard deviation is 15. Okay, there you go. So here they even tell you, well, you see what I was telling you in the other video. Here they don't tell you specifically the numbers. And I guess you can change that. You can see which one you're going these numbers to go off by. But I mean, this is just a simple addition. So to create the horizontal axis here, you just have to add and subtract, right? Once you figure that out, okay, then you need to tell me what is the duration between 253, what's the percent, and 283 days. But if you have technology, okay, like in this case, you don't, oh my gosh, they already knew. They already knew that that's what I was looking for. No, I'm just kidding. That's just within one standard deviation. Maybe two. Let's see. Yeah, within one standard. So they already know, you by now, hopefully, you will be able to see that this is within one standard deviation of the mean. So the program doesn't lie, right? Like if you go back here, yes, you can use the empirical rule. You can. But I didn't want to use it in this case. I wanted to show you how you can use technology to like do it even faster. You know that 34 and 34 will add up to 68. And that's exactly what it says here. That the average, that the area for the curve will be 0.68%. And yeah, that's exactly right, right? That will be right. It will be 68%. So approximately 68% of pregnancies last between 253 and 283 days. So go back and finish the rest of the skills practice that I provided you, and hopefully this is a little bit cleared, and I hope that you score a better grade in this test than in the last one. Reach out if you have any questions.